Okay, so for this first lesson, all it is like an introduction, so a review of radicals and how to simplify radicals, and an introduction to what I is, which is going to be a new class of numbers, which is imaginary numbers, okay? So with radicals, okay, to start with, you've all seen a radical like a square root, okay? If I have the square root of 5, what we call the square root is actually called the radicand. Well, it's called the radical, and this number is your radicand. Now, you don't ever write a 2 for a square root because it's understood to be that, but usually anything other than a 2 has a number there, and that is your index. So if there's no number, it's understood to be 2 for a square root. If it's a cube root, you will have a little 3 over that radical. So cube root of x to the 5th. X to the 5th would be your radicand. 3 would be your index. Okay? Right now, we're only looking at square root. But I want you to make sure you understand that because later on we're going to do bigger indexes, okay? So to simplify radicals, you're going to always check for perfect squares. If you don't already know them, in your calculator, you can type right here. Well, y'all can't see that with the glare. That's your square root button. So if you didn't know what it was, say 72, gives me a decimal, so it's not a perfect square. But if I did square root of 49, gives me a whole number, so it is a perfect square. Okay? So when you get the decimal, that's when you're going to have to do a prime factor tree. Okay? When I do prime factor trees, I can't talk, I divide either by a 2, a 3, or a 5. That gives me an organized tree that all goes to the right. Sometimes some people do different numbers, and that's totally fine. I'm not going to count off if you don't divide by 2, 3, or 5. That's just going to give you a clean tree, okay? What you're going to do also is when you have pairs, you're going to circle each pair, and you're going to box in the leftovers that are unpaired, okay? So those are your leftover prime factors. So when you're doing that, it takes 2 of the same prime factor to write that one factor on the outside, okay? That sounds confusing, but you've already done this. When I start doing it, you will know what I'm talking about. So all of the things that are circled comes on the outside of the radical. All the things that are boxed stay under the radical. Pairs go outside, unpaired stays left over, okay? So if I have multiple pairs, you're going to multiply those. If I have multiple factors left over, not paired, you're going to multiply those and put it together, okay? So with the square root of 176, okay, check first if that is a perfect square, which it's not. So we're going to start with our prime factor tree. Okay, so if I take 176 and divide it by 2, that's going to give me 88. And then I'm going to take that 88 and I'm going to split it 2 and 44. Y'all remember doing this? Okay. 44 will split 2 and 22. 22 will split 2 and 11. So now we're going to look at our pairs. So I've got a pair of 2's here and a pair of 2's here. My 11 is left over. Okay, so what's going to happen is each circled pair, I take out that one factor. Okay, so I'm going to have 2 times 2. And then my 11 stays under the radical. So each circled pair, I take that one number out. It's just that one factor. Okay, and then 2 times 2 is 4 square root of 11. You should have simplified radicals in geometry. Yeah, okay. So then now I've got 2 times the square root of 12, so I'm going to take 12. I know that's not a perfect square. That's going to split into 2 and 6. 6 will split into 2 and 3. So I have, bless you, a pair of 2s with a 3 left over. Okay, now be careful. You already have a 2 on the outside. That 2 comes down, and I'm going to multiply that with the 2 that I paired. And then my 3 is left over. So anything that's already on the outside, you multiply that by whatever you pair together. Okay, so this becomes 4 square root of 3. Now you can check this. It's not going to guarantee that you got the simplest form, but you can check it. If you type, this glare is not working out in my favor. If you type, say this first example, the square root of 176, we got 13 point, that whole decimal. Type your answer for square root of 11, and those 2 decimals should be the exact same. So you can make sure the value of your answer is equivalent to your original problem. Okay, so if you wanted to check it, you can do the same thing, 2 square root of 12, and then 4 square root of 3. They give me the same decimal, so I'm good. Okay? Questions? All right, so the square root of 20, I know that's not a perfect square, so I'm going to split 20 into 2 and 10. 10 will split 2 and 5. So I have a pair of 2s with a 5 left over. So I bring the negative down, and I'm going to multiply that by my 2 with my 5 left over under the radical. So that gives me negative 2 square root of 5. That should be simple. Okay? Questions? Okay, now we're going to look at what happens when you take the square root of a negative number. Okay? So if you take the square root of negative 1, that's equal to I, which is imaginary. So you know you can only take the square root of a positive up until this point. Now if you have a negative, you're going to split that. So if I'm looking at the square root of negative 5, that's really the square root of negative 1 times the square root of 5. Take that negative 1 out, okay, into its own thing. Now the square root of negative 1 is I. So I'm going to replace that with I. I'm going to check, can I simplify the square root of 5? No, it's just 5. So it's going to be I square root of 5. This you cannot check imaginary in this calculator. Yes?
Do I have to write the I first?
Oh, no, it's just the way that I write it. You're fine. As long as I know it's an I, you're good. Okay, so then when I look at the square root of negative 4, that's going to split into the square root of negative 1 times the square root of 4. Okay, and I said the square root of negative 1 is I. And then the square root of 4 is what? 2. Alright, when you write your imaginary parts, okay, if you have a radical, it goes in the front. But if you have a whole number, it had a perfect square, it's 2I. So that I goes behind that perfect square. Okay? It goes in front of a radical, but behind what this would be. Okay? So if I have the square root of negative 24, that gives me the square root of negative 1 times the square root of 24. Square root of negative 1 I know is I, but the square root of 24 I need to simplify. So I'm going to take 24, and I'm going to split that into what? 2 and 12. 12 can split 2 and 6. 6 can split 2 and 3. So I have a pair of 2s, and my 2 and my 3 are left over. Okay? So I'm going to bring out this 2, and then I've got 2 times 3 under the radical, which is going to give me 6. So you multiply the 2 and the 3 together. So now, how do I write that? 2I square root of 6. We good with that? Okay, just the moment you see a negative, just know you have to take an I out, okay? So now I've got negative 3 times the square root of negative 121, so that's going to give me square root of negative 1 times the square root of 121. So I'm going to bring down this negative 3, bless you. My negative 1 is an I. What's the square root of 121? 11. So I've got negative 3 times I times 11. So my final answer would be what? Negative 33I. Very good. Okay, so now I've got 5 square root of negative 72. So I've got square root of negative 1 times the square root of 72. I'm going to bring down this 5. I know that the square root of negative 1 is I. And then I need to simplify 72. So that can split 2 and 36. 36 can split 2 and 18. 18 can split 2 and 9. 9 can split 3 and 3. Okay? So I have a pair of 2's and a pair of 3's. And this 2 left over. So I've got 5 times I times this 2 that I paired times this 3 that I paired, square root of the 2 that's left over. You'll follow me? Okay. So 5 times 2 times 3 is going to give me, so 30I square root of 2. Okay, y'all do the next one, and then we're going to check it. Okay, you should have split that square root of negative 40 to the square root of negative 1 times the square root of 40. Okay, and then 40 you simplify. That's 2 and 20, 2 and 10, 2 and 5. So you have a pair of 2's with a 2 and a 5 left over. So you should have had negative 2 times I times 2 square root of 10. So your final answer should have been what? Very good. We good with that? All right. So adding and subtracting radicals, okay? The index and the radicand, the number underneath your radical, has to be the exact same for it to be considered like terms. Okay? Then what you're going to do is add and subtract your coefficients, but you're not going to change your radicand, the number underneath the radical. So think about when you take 2x plus 3x. What does that become? 5x. See how you did not change that x? So it's like the same thing with a radical. If I have 2 square root of 3 plus 3 square root of 3, all I'm doing is taking the coefficients and adding those, but I'm leaving what's under the radical. Okay? So they have to be like radicals for you to combine them. Majority of the time they're not going to start that way, so you're going to have to simplify it to make them that way. Okay? So here, if I've got square root of 3 plus square root of 3, those are already like radicals, okay? My coefficients aren't written, so it's understood to be 1. So 1 plus 1 will give me 2 square root of 3. Now, these don't have imaginary, so you can type this in your calculator and check to make sure your values are the same, okay? Now I've got 7 square root of 5 minus 12 square root of 5. Those are like radicals, so I'm going to take 7 minus 12, and that's going to give me what? Negative 5 square root of 5. Very good. So square root of 12 plus square root of 75, those are not like radicals. So I'm going to have to simplify both. I'm going to take 12. And that splits 2 and 6, 2 and 3. So I have a pair of 2's with the 3 left over. So square root of 12 simplifies to what? 2 square root of 3, very good. And then 75, I can split that. You can either do, so it's not a 2, because it's not an even number. You can either do 3 or you can do 5. Okay, if you do 5 and 15, 15 can split into 3 and 5. You could have done 3 and 25. That's my go-to, 3 and 25. Either way, you still would have gotten a pair of 5's with the 3 left over. So this becomes 5 square root of 3. Now that I have simplified them, they become like radicals. I can add them, and my final answer would be... Very good. Okay, so 3 square root of 2 plus square root of 18. Square root of 2 I cannot simplify, so I leave that as is. But I can take 18 and I can break it down into 2 and 9. And 9 breaks 3 and 3. So I have a pair of 3's with the 2 left over. So 3 square root of 2 plus 3 square root of 2. What's that going to give me? 6 square root of 2. We good? Alright. So now we've got 2 square root of 8 plus 5 square root of 2 minus 4 square root of 3. I need to take this 8 and break it down. That can split into 2 and 4. 4 splits 2 and 2. So I have a pair of 2's with the 2 left over. So 2 square root of 8, remember I already have a 2 out here. So I'm going to take that 2 and multiply it by the 2 that I paired with this 2 left over. Okay, now can I simplify 5 square root of 2? Can I simplify 4 square root of 3? No. So this just becomes 4 square root of 2 plus 5 square root of 2 minus 4 square root of 3. I just bring those down. So I can only combine like terms, so like radicals. So 4 plus 5 is going to give me 9 square root of 2, and that minus 4 square root of 3 I cannot combine with anything. It is okay to have 2 separate like radicals. You don't always have to come down to one specific term. If there's not like radicals, you can't do anything about it. Okay? And again, you could type this whole thing in your calculator, get the decimal, type this in your calculator. It should be the same decimal. Okay? Questions on that section? Okay, so now we're going to move on to multiplying radicals. Your index has to be the same, but the radicand does not. Okay, so think about if you multiply 2 times 3x. What does that become? 6x. Notice that you only multiplied the numbers by each other and you didn't do anything with the x. Okay? So if you have, say, 2 times square root of 3, that's like saying 2 times x. If all I had was 2 times x, what would that become? 2x. You just put them together. So if I have 2 times square root of 3, that just becomes 2 square root of 3. You just put them together if it's not number, number, radical, radical. Y'all get what I'm saying by that? Okay. If I have square root of 3 times square root of 15, those are both radical, radical. So what's going to happen is I multiply the numbers underneath the radical, and I put that under the radical. If it's radical, radical, it stays radical. Okay? So square root of 3 times square root of 15. I can't simplify 15. Yes, it breaks apart, 3 and 5, but those don't pair. Okay? So if you could simplify, you would do that first, but I can't. So this just becomes square root of, what's 3 times 15? 45. Now I can check to simplify that. Okay, so I'm going to take 45, and that splits 5 and 9. 9 splits 3 and 3. So I have a pair of 3's with a 5 left over, so it would simplify to what? 3 square root of 5. Okay. Now I've got 3 times the square root of 7 squared. Anytime you see something with a radical squared, that means you write it twice and then multiply. Just like 4 squared is 4 times 4 to get you your 16, 3 times the square root of 7 squared is going to be 3 times the square root of 7 times 3 squared times the square root of 7. Just write it twice. Okay, so I'm going to multiply outside times outside. 3 times 3 gives me 9. And I'm going to do radical times radical. And 7 times 7 gives me 49. Y'all follow me on that one? Okay. Now, the square root of 49 is what? 7. So 9 times 7 is 63. Okay. So now I have 2 minus the square root of 5 squared. So that means I'm taking 2 minus the square root of 5 and writing that twice. Now I have 2 terms in each set of parentheses. That's like when I have x minus 2 times x plus 3. Something like that. What would you do if you had this? You would FOIL it. Okay? You're going to FOIL this. So I'm going to take 2 times 2. That's number times number. So that gives me 4. I've got 2 times a negative square root of 5. So I'm going to take the negative. I've got a number times a radical. So I just put those together, 2 square root of 5. That does not become square root of 10. They're different terms. Okay? So now I've got negative square root of 5 times 2. It should be the same as this because you wrote it twice. So I've got another negative. My outside number is 2. My square root of 5 stays the same. Then I've got negative square root of 5 times negative square root of 5. Negative times negative is a positive. I have radical times radical, so I multiply them and it becomes square root of 25. Are we okay with that? So now I need to simplify what I can. So I need to combine like terms if I have like terms and simplify my radicals if I can. So I know that negative 2 square root of 5 minus 2 square root of 5 is negative 4 square root of 5. And I know that the square root of 25 is what? 5. So I've combined my like terms, I've simplified my radical, now I need to combine like terms again to get a final answer. So I'm taking 4 plus 5 to give me 9 minus 4 square root of 5. If you make minor mistakes in your details, I would really make sure you take your time when you have to FOIL and distribute, okay? So now let's say we've got square root of 3 times 2 square root of 2 plus 4 square root of 6. Okay, now my numbers are a little bit bigger, as in I've got an outside and radical for both of these terms. So when I take square root of 3 and I distribute it, I'm going to take the square root of 3 and only multiply it by its radical part. That outside number stays the same. So square root of 3 times 2 square root of 2 is going to become 2 square root of 6. Okay? And then I'm going to take square root of 3 times 4 square root of 6, and again, only do radical times radical, so that 4 stays, and then I've got the square root of 18. Now I simplify. 6 can break into 2 and 3, but I can't pair anything. 18 will be 2 and 9. 9 will split 3 and 3, so I have a pair of 3s with a 2 left over. So 2 square root of 6 comes down, plus I've got 4 times the 3 that I paired with the square root of 2 that's left over. So I have 2 square root of 6 plus 12 square root of 2. I cannot combine those because they're not like radicals, so that is my answer. You good with that? Other questions? So now I've got 3 squared root of 15 times 6 squared root of 18. Every little problem is different with what you're given. You just have to know outside times outside, radical times radical. Okay? So outside times outside, 3 times 6 is going to give me 18. I'm going to show you two ways here. Okay? Then I would do radical times radical, 15 times 18, and you get a really large number. This is going to be a majority of y'all's first instinct. Okay? You're going to take 15 times 18, and you get 270. Then you're going to take 270 and split it. That'd be 2 and 135. It ends in a 5, so I can divide it by 5. Gives me 27. 3 and 9. 3 and 3. So I would have a pair of 3s. A 3, a 5, and a 2 are all left over because I can't pair them. So that would be 18 times 3 square root of 2 times 5 times 3 would give me 30. 18 times 3 is 54 square root of 30. Okay? Most of the time when I'm looking at tests, that's the first instinct. But what might make your numbers, if you don't like large numbers, what might make them smaller is if you check to simplify. I could have simplified this 18. Okay? So I'm going to show you that. If I take 3 square root of 15, that does not simplify because that's just 3 and 5. 6 square root of 18, I already broke down my 18 right here. So that would be 6 times the 3 that pairs. So 18 times the square root of 2. So 3 times 18 is my 54, square root of 30. I get the same answer either way. You would check to simplify 30, but you can't. I don't care which way you do it, as long as you show me in all your work. Okay? Questions on that? Now this next one. If you write large, write a little bit small. I've got 3 square root of 6 plus 4 square root of 7 times 2 square root of 2 plus square root of 3. What am I going to do with all of this? Check to simplify, which I can't. And then I'm going to FOIL. 3 square root of 6 times 2 square root of 2. I've got outside times outside, which gives me 6. And radical times radical, which gives me square root of 6 times 2 is 12. Then I'm going to do it again. I take 3 square root of 6 times square root of 3. Now that square root of 3 doesn't have an outside, it's really a 1. So 3 times 1 is just 3. And then I'm doing radical times radical, so square root of 6 times square root of 3 is 18. Plus, now I'm going to do 4 square root of 7 times 2 square root of 2. So I do outside times outside. 4 times 2 is 8. Square root of radical times radical. 7 times 2, 14. Then 4 square root of 7 times 1 square root of 3. Outside 4 times 1 is 4. And then radical times radical, square root of 7 times square root of 3 is 21. And then I check to simplify. Okay. 12, I can split. That's 2 and 6, which splits 2 and 3. So I've got 6 square root of 12. So that 6 times this 2 becomes what? 12 square root of 3. Plus 3 square root of 18. Square root of 18, I've already simplified over here, so I'm not going to do it again. Okay? That 3 comes out and is multiplied by this 3. So that becomes 9 square root of 2. Y'all following me? 8 square root of 14. 14 just splits into 2 and 7. I can't pair that, so that doesn't change. Same thing with 21. 21 is just 3 and 7. So that doesn't change either. Bless you. There's nothing I can combine, so even though it looks like it wouldn't be my final answer, that's all I can do. Okay? Do we have questions on that? We get to flip? Okay, now we're going to talk about rationalizing. So our quotient property tells us if you have the square root of a over b, you can separate that radical into the square root of a over the square root of b. Okay? The reason we rationalize the denominator is because you cannot have radicals in the denominator of a fraction. You have to get rid of it. Okay? So if you notice, earlier when we did square root of 7 times square root of 7, that gave us the square root of 49, which ultimately gave us 7. Same concept, if you've got the square root of 5 times square root of 5, that's going to give you square root of 25, which is 5. Okay, you see what's going on here? So if I have the square root of a times the square root of a, ultimately that's just going to give me a. This concept right here is what we use to rationalize the denominator. If you want to get rid of a radical, you have to multiply it by itself for it to just become that factor or that radicand. Okay? So what you're going to do is simplify as much as possible. You're going to check for your perfect squares. You're going to simplify your coefficients if you can, or even though you've got a fraction with radicals, you can simplify a radical over radical. Okay? There's going to be some examples where if you do that, it makes your numbers easier. If you don't, that's okay. You just have larger numbers. You simplify later. Okay? So if I look at the square root of 9 over the square root of 25, or square root of 9 over 25, split that square root of 9 over square root of 25. Always split it. Now I can see square root of 9 is what? 3. Square root of 25 is 5. I don't always have to rationalize. That was a perfect square. Okay? If I look at square root of 75 over 8, I need to separate square root of 75 over square root of 8. Now, square root of 75 is not a perfect square, neither is square root of 8. So then I check, can 75 over 8 simplify? If you don't know your numbers and their relationships, if you type, first check your mode. Y'all's modes are not staying in the same spot. Make sure when you hit mode, those two, when you go all the way down, these two are highlighted. Some of y'all are not, I don't know what's happening from class to class, but they're not staying that way. You want it to be auto-simplify for you to check if it simplifies. Okay? Does everyone have their mode fixed? Okay. So second mode will get you out of that. So if you type your fraction, 75 over 8, if it gives you the same fraction, it cannot simplify. Okay? But if it would have been something like 75 over 15, it would simplify for you. So it would let you know you could. Okay? If I can't simplify the fraction, I'm going to see, can I simplify the radical? I can take 75 and do a prime factor tree. Okay, that would give me 3 and 25. 25 gives me 5 and 5. And I can take 8 and break it down, 2 and 4, 2 and 2. Follow me? So the square root of 75 on my numerator is now what? 5 square root of 3. That square root of 8 on my denominator is now 2 square root of 2. Now what did I say you couldn't have in the denominator? A radical. I didn't say you couldn't have a number. That's fine that you have a number. So all we're looking to get rid of is that square root of 2. So what I'm going to do is I'm going to multiply the numerator and the denominator by that radical. I don't need to do 2 square root of 2 because the 2 is not my problem. The square root of 2 is my problem. Okay? So you multiply top and bottom. So when I do 5 square root of 3 times square root of 2, I do radical times radical. So that becomes 5 square root of 6. Okay? This 2 on the outside stays, and I multiply that. If I had square root of 2 times square root of 2, what does that ultimately become? 2, because it's the square root of 4, which is 2. You do not, at rationalizing, you should know you multiply it by itself to get rid of the radical. You don't have to tell me square root of 4. Okay? So this simplifies to 5 square root of 6 over the 4 that I now get. I would check to simplify 5 over 4, those outside numbers. I cannot. So that is what it is. You do not change the number under the radical once you've multiplied though. Okay? Any questions on those steps? So now I've got 2 square root of 6 over 5 square root of 10. I'm going to check, can 2 over 5 simplify? No. So then I'm going to check, can 6 over 10 simplify? They're both under radicals, right? So I can do outside and outside simplified and radical times radical. Not radical times radical. Radical and radical. So if I did 6 over 10, just the numbers, that simplifies to 3/5. So I can make it easy on myself, and this becomes 2 square root of 3 over 5 square root of 5. Because 6 over 10 simplifies to 3 over 5. It just stays under the radical. Okay? So now, instead of rationalize the square root of 10, I'm going to rationalize what? The square root of 5. So when I rationalize, I multiply top and bottom by itself. So I'm going to multiply square root of 5, square root of 5. So 2 square root of 3 times square root of 5 is going to give me what? Very good. And then this outside 5 comes down. And then square root of 5 is just going to be 5. So that's going to be 2 square root of 15 over 25. I would check my outside numbers. Can 2 and 25 simplify? They cannot. There's my answer. And you can still type this in your calculator, get a decimal, this in your calculator, get the same decimal. Okay? I know this is a lot. Do y'all have questions? Rationalizing shouldn't be new though. You should have done that when you had, what, special right triangles is usually when the radicals come in. Okay. So something like this might be new where you have more than just one number. Okay? So I've got 3 minus 2 square root of 2 over 4 square root of 3. Cannot simplify 2, cannot simplify 3. So I just start rationalizing. So what am I going to rationalize by? Square root of 3. Now my numerator is a binomial. I have 2 terms. So I'm going to take that square root of 3 and I'm going to distribute it to every term in that numerator. So 3 is an outside number times square root of 3, which is a radical. I'm just going to combine those. 3 square root of 3. Minus, I have an outside number of 2. This is really a 1, so 2 times 1 is going to be 2. Square root of 6. Then my denominator, I take this 4, and it comes down. And square root of 3 times square root of 3 is 3. So that gives me 3 square root of 3 minus 2 square root of 6, because I can't simplify that, over 12. Now you would check to simplify all of your outside numbers, 3, 2, and 12. They would have to be divisible by all the same, which they're not. They look like they would be, but 3 and 2 can't be divided by the same number. So that would be my final answer. If it were 3, 9, and 12, I could simplify all of those. Y'all want to try this next one on your own? Okay, let's try it, see if you've got it down. Okay, if you don't know where to start, you should start by asking yourself, can I simplify anything? I cannot. So then, what do I need to get rid of? So I multiply by square root of 5 over square root of 5. So I'm going to distribute that. And that becomes 10 square root of 5 plus 5 square root of 10 over, bring down your 6 and multiply that by 5. So that gives me 10 square root of 5 plus 5 square root of 10 over 30. And then I would check. 10, 5, and 30. Can those be divided by the same number? Yeah, they can all be divided by 5. So 10 divided by 5 is 2 square root of 5. Plus 5 divided by 5 is 1 square root of 10. 30 divided by 5 is 6. So I noticed a lot of y'all didn't even start that. So always ask, can I simplify? If not, what do I get rid of? Okay? No questions on that section. Now we're going to use conjugates to rationalize. Okay? So if I have a plus the square root of b, its conjugate is a minus square root of b. Same exact thing, just different sign in the middle. Okay? If I have a minus square root of b, its conjugate is a plus square root of b. The signs of a do not change. It's only the sign of the middle which affects your last term. Okay? So, if I have a plus b times a minus b, okay, if I FOILed that, a times a would give me a squared, A times negative B would be a negative AB. B times A would give me BA, or AB. Negative B squared would be what I end with. The negative AB plus AB is what cancels, and that's how I get A squared minus B squared. There's a formula to conjugates, okay? Every single time you have a conjugate, those middle terms cancel. And we're going to use that formula to our advantage. So when you have A plus the square root of B times A minus the square root of B, you're taking your first term and squaring it. It will always be minus because you have positive times negative. And you're taking your second term and squaring it. Okay? So an example, if I have 2 plus the square root of 3 times its conjugate, which is 2 minus square root of 3. Okay? I recognize they're conjugates because it's the exact same thing, just one's a plus, one's a minus in the middle. So what I do is I take that first term, which is 2, and square it, minus my second term, which is square root of 3, and square it. That's my formula. So 2 squared is 4, minus square root of 3 squared just gets rid of that radical, leaving me with 3. 4 minus 3 is 1. Okay? You're going to have to know the formula and how it works. That's what we're going to use to rationalize. So they're going to be used to remove the radical. So you should end up with a constant in your denominator. Okay? You're only going to use conjugates when the denominator has 2 terms. The last page, the numerator had 2 terms, but the denominator was still only 1. Okay? So when you see a plus or minus in the denominator, that's when you use its conjugate. Okay? So I've got 3 over 7 plus square root of 2. I can't simplify anything, so I'm going to multiply by its conjugate, which is 7 minus square root of 2. Multiply top and bottom by that. So my numerator, 7 minus square root of 2 times 3, I'm going to distribute that 3 to everything. So 3 times 7 is 21. 3 times negative square root of 2 is a negative 3 square root of 2. Alright, now I know I've got a conjugate, so I'm going to do my formula. So I take my first term, which is 7, and I'm going to square it. Always going to be minus. My second term is square root of 2, and I'm going to square that. Okay, so my numerator, 21 minus 3 square root of 2, I just copy down. 7 squared is what? 49. Minus square root of 2 squared just cancels the radical, leaving me with 2. So I have 21 minus 3 square root of 2 over 47. I checked to see if I can simplify my outside numbers, 21, 3, and 47. I cannot, so this is my answer. Okay. So I have 7 minus 2 square root of 5 over 2 plus square root of 5. Can't simplify, so I'm going to multiply by its conjugate. What's my conjugate? 2 minus square root of 5. All the exact same things, just change the sign in the middle. Alright, now my numerator, I have 2 terms in both. Anytime you have 2 terms that you're multiplying, you're going to FOIL. So 7 times 2 gives me 14. 7 times negative square root of 5 is a negative 7 square root of 5. Negative 2 square root of 5 times 2 is a negative 4 square root of 5. then a negative 2 square root of 5 times negative square root of 5. Negative times negative is a positive. And that gives me 2. Square root of 5 times square root of 5 is what? 5. So 2 times 5. And 2 times 5 is what? 10. Okay. Now my denominator, they're conjugates. So I take my first term, which is 2, and square it, minus square root of 5 squared. So I need to clean up my numerator. 14 plus 10 gives me 24. Negative 7 square root of 5 minus 4 square root of 5 gives me what? Negative 11 square root of 5. Then my denominator, 2 squared, is 4 minus square root of 5 squared is 5. Okay, so that's 24 minus 11 square root of 5. 4 minus 5 is negative 1. I cannot leave it like this. Never leave a negative in the denominator. This is a negative 1. It's easy to just take those divided by negative 1. But if it were to have been a negative 3, I would take all the signs and just alternate them because you're dividing by a negative 1. Okay? So if you're left with a negative in the denominator, just take it out and all the signs change. Okay? So my final answer here is negative 24 plus 11 square root of 5. Okay. Do you want to try the next one? Try it. It's our last example. Okay, what's my first step? See if you can simplify what you can't. So then the next thing is your conjugate, which was what? So then what does my numerator become? So 4 square root of 6 plus square root of 12. Because this is outside times radical, so you just combine them. And then radical times radical, you multiply. Okay, then my denominator becomes now 4 square root of 6 I cannot simplify, but square root of 12 simplifies to, should have caught that to be 2 square root of 3. And then your 4 squared is 16 minus square root of 2 squared should have been 2. So you get 4 square root of 6 plus 2 square root of 3 over 14. Did you leave it there? If you got there? Who got there? Okay. Should have recognized outside numbers 4, 2, and 14 can all be divided by 2. So 4 divided by 2 is 2 square root of 6. 2 divided by 2 is 1 square root of 3. 14 divided by 2 is 7. This is a lot of information in one lesson. The whole unit is going to be like this. Okay? I want you working the rest of the period on whatever section you didn't fully grasp in the notes. If you know how to add and subtract radicals, don't do that. Do what you struggle with while you're in here with me so you can ask me the questions and you don't get stuck at home not knowing what to do. Okay, so I want you working and I don't want phones out. I want you working. Okay, y'all got 30 minutes to the bell. 33, but 30 minutes to work.